So, have you ever really stopped to think about what happens in those first critical hours when a severe infection takes hold? We're about to dive into one of the most high stakes decisions in all of medicine. It's a choice that isn't just about saving one life right now, but also about protecting our future ability to fight disease at all. Okay, let's put you in the moment. Imagine someone you love is in the ER. They have a really bad infection, and you can just feel the urgency in the air. The clock is literally ticking. The doctors have this whole arsenal of antibiotics, but which one do they choose? How do they pick the right weapon? It's an incredibly complex decision. Because you see, this isn't just about wiping out the bacteria in that one person. It's a massive balancing act. On one side, you have the immediate, desperate need to save a patient. And on the other, you have this long-term global threat of creating superbugs that are resistant to our very best medicines. All right, so let's start with that immediate crisis. When a really bad infection starts to overwhelm the body, doctors are in an absolute race against the clock. And the dangerous condition they're fighting? It's called sepsis. Now, here's something a lot of people get wrong. Sepsis isn't the infection itself. It's actually the body's own chaotic, over-the-top reaction to the infection. Think of it like friendly fire. Your immune system is trying so hard to save you that it starts attacking your own tissues and organs. And that's what makes it so deadly. So what's with this number 3? Well, that's 3 hours. This is the critical 3-hour window. There's a rule called the SEP1 measure that basically says for patients with sepsis, doctors have to start a whole bundle of treatments, including antibiotics, within 3 hours of that patient showing up in the ER. So yeah, the clock is officially and unforgivingly ticking. With that kind of insane time pressure, and without even knowing the exact bug they're fighting, what can doctors possibly do? Well, they start with what you might call the sledgehammer approach. This initial attack is officially called empiric therapy. And what that really means is it's a powerful, evidence-based, educated guess. See, doctors take samples to grow in the lab and figure out the exact bacteria, but those results can take days. They don't have days. They have hours. So they have to act now. And that means using antibiotics that can kill a whole bunch of potential culprits. These broad-spectrum antibiotics are the heavy artillery for really scary stuff like flesh-eating bacteria, or for patients whose immune systems are shot. The guidelines often recommend a powerful cocktail like vancomycin plus piperacillin tazobactam. The whole idea is to cast the widest net possible to make sure you hit the target when the stakes are this high. But here's the catch. Using a sledgehammer is messy. It comes with risks. This powerful, life-saving approach has a pretty significant downside, an unseen cost that, in the long run, we all end up paying for. And this right here is the heart of the problem. The sledgehammer, it saves lives when you're flying blind, no question about it. But using it too much drives antibiotic resistance. It can wipe out all the good bacteria in your gut and lead to other nasty infections like C. diff. And it's expensive. The alternative, a narrow-spectrum antibiotic, is like a surgeon's scalpel. It's precise, it's safer, but it's totally useless if you don't know exactly what you're targeting. So the main takeaway here is this. These drugs are absolutely essential to start with, but relying on them for too long is speeding up one of the biggest public health crises we face. We're actually creating a future where a simple infection could become a death sentence all over again. So how do we fix this? We can't just stop using these life-saving drugs. Well, this is where modern medicine gets really smart. There's an intelligent strategy to move from that initial sledgehammer to a much more precise surgical scalpel. The process is called antimicrobial de-escalation. It's a key part of a bigger concept known as antimicrobial stewardship. The whole idea is that it's not just about what antibiotic you start with, it's about having a smart plan to refine your attack as you get more information. So here's how it plays out for the patient. They arrive, and right away, cultures are taken. Then, within that 3-hour window, the sledgehammer antibiotics get started. Then comes the waiting game. After about 2 or 3 days, the lab results finally come back. They've identified the bad guy and exactly what will kill it. That is the moment of truth. That's when doctors can safely switch to that targeted scalpel. And listen, this isn't just some fringe idea. This is a core recommendation from groups like the Surviving Sepsis Campaign. The goal is always to de-escalate as fast as humanly possible. Why? Because every single hour a patient is on an unnecessarily broad antibiotic is another hour we're contributing to the global resistance problem. But hold on, it gets even more complicated. Choosing the right drug and knowing when to switch is only half the battle. Getting the dose right is just as critical because when it comes to the human body, one size definitely does not fit all. Just take obesity, for example, which is incredibly common now. An obese person's body processes drugs completely differently: how they're absorbed, where they go, how they're eliminated. If you use a standard dose, you could cause toxic side effects, or, just as dangerous, the dose could be so low that it fails to work at all. So, how do doctors deal with this? Well, it's not as simple as just using the number on the scale. They have a few different options. There is the patient's actual or total body weight. There's ideal body weight, which is based on height, that can sometimes lead to underdosing. And then there's something called adjusted body weight, which is a special formula that tries to find a middle ground. It's all because different drugs distribute into fat tissue differently. And this is where it gets super specific. For a drug like vancomycin, you actually dose based on the patient's total weight. But for another class, aminoglycosides, you use that adjusted weight. And for a huge group of drugs called beta-lactams, which includes penicillin, obese patients often need higher doses or even infusions that run over a much longer time just to be effective. It's an incredibly tailored process. And on top of all of that, before they even give the first dose, doctors have to play detective. They assess the patient's risk for a drug-resistant superbug like MRSA. Have they been in a hospital recently? Is MRSA common in their community? The answers to those questions help them decide if that initial sledgehammer needs to have an extra anti-MRSA component right from the very start. So, as you can see, treating a severe infection isn't just one decision. It's a dynamic, constantly shifting process that demands an incredible amount of skill, knowledge, and judgment. So if we boil it all down, here's the modern playbook. Step 1, start broad and fast. Hit that infection hard to save the life. Step 2, gather intel. Get those cultures to the lab to identify your enemy. Step 3, and this is the crucial part, de-escalate and refine. Swap that sledgehammer for a scalpel as soon as you can. And step 4, tailor the dose. Constantly adjust based on the individual patient. That right there is modern antimicrobial stewardship. And it's not just about the right drug, it's also about the right duration. The goal is always, always, always to use the absolute shortest course of treatment that will work. Every extra day on an antibiotic is just an unnecessary risk, both for the patient and for all of us. Which brings us right back to that huge central question. Every single day in ERs all over the world, doctors are making these tough calls. They're performing this incredible tightrope walk, saving the life of the person right in front of them while trying desperately to protect our most precious medicines for all the people who will need them tomorrow. It's a dilemma that, right now, has no easy answer.